Alright, for section 7.4 here, our example is a researcher claims that less than 20% of its students have a major in business. You believe that the claim is incorrect. You collect a sample of 50 students and ask them what their major is, and find that 28% of the students major in business. Use this information to test the claim at alpha equals 0.01. So just like before, we want to set up our null and the alternative hypothesis first of all here. And we're dealing with a proportion here, so that means we're dealing with P. And in this particular case, the claim that we're testing is this researcher's claim that less than 20% have a business major. So less than, remember, would be an alternative hypothesis. So that means the claim in this case is that alternative hypothesis there of 0.2, and that would be our claim, because if it has a not equal to part, if it doesn't have that equal to part, then it's alternative. The null then is the opposite, which would be greater than or equal to that 0.20 in this case. So here then we have that it is a left tail test because this alternative hypothesis here is less than. The alternative is always what tells us what type of test it is. So whenever we're going through and sketching our rejection region here, since our alpha level is 0.01 and we have a left tail test, that means the area in this particular region needs to be 0.01. To look that up for the corresponding z-score value there, once again, we want to go through and look for the value in the area. So in the center part, that is closest to 0.01. So if we look that up in the table here, the one that is closest to 0.01, in this case, looks like it's a 0.099. So it's very, very close to 0.01. And that z-score value there is a negative 2.33. And that's also where in the book they have this labeled as z sub 0 as that critical value there. And then remember, we also have to go through, for these type of problems, find the z-score. So this test statistic is what this one is called. So to do this here, we have formula, which will be given to you also if you need it on like a quiz or a test. It is p hat, which means your sample proportion, minus p, which is the population proportion, all over the square root of p, the population proportion, times q, the proportion of failure related to that population value, because remember, P is probability of success, Q is the probability of failure, all divided by N. All of that is underneath that square root symbol. So in this case, our P hat, the proportion from our sample, is 0.28, and then our population one is 0.20 or 0.2, all over the square root of, in this case, our P once again is 0.2. And then we have to multiply that times Q. Remember, Q you find by doing 1 minus P. So 1 minus P here, we get 0.8. So we have 0.2 times 0.8. And still underneath that square root symbol there, we divide that by our sample size, which in this case is 50. So then if we calculate that here, we get approximately 1.41. And then remember, we have to test to see if that test statistic is in the rejection region or not. So in this particular case, if we look at that 1.41, it is definitely not in the rejection region. So remember, if it's not in the rejection region, that means that we fail to reject null hypothesis. Remember, the null hypothesis is your h sub 0. And then remember, for all of these, we also need to do our interpretation here. So in this case, our statement here would be that there is not enough evidence at our alpha equals 0.01 level to, and then remember, the interpretation always needs to be in terms of the claim, what you're stating about the claim. So we already said we're failing to reject the null hypothesis. So in this case, that means we do not have enough evidence in this case to support the claim, because the claim was the alternative hypothesis here. So make sure you're careful with those. So we don't have enough evidence to support the claim, and then you write out what the claim was in this case. That the p is less than 0.2. And then one thing to keep in mind here also, that for these, I didn't write it down up above, but in general here, you should be checking to make sure that the conditions are met to be able to do all of this. In this case, I already knew that they were, that your n times p has to be greater than or equal to 5, and also that your n times q has to be equal to greater than or equal to 5. Both of those have to be true. So like in this case, your p is 0.2, your n is 50. If you do 50 times 0.2, it's definitely a lot bigger than 5. And so is 50 times 0.8. Both of those were greater than or equal to 5, so that's definitely true in this case. In general, you'll want to make sure to double check that, because if those are not both satisfied, then there's no point of even doing all this other work here, because you could just state that you can't go any further. You can't go through and do the test because you don't have enough for your sample size. Your sample size is not large enough. Also keep in mind, if these interpretations are still giving you problems, on page 364 in your book is where you can look at for more help with those interpretations. Again, that's on page 364 to help you with those interpretations there.